Hello all, welcome back to Engineering Economics. We are talking about comparing alternative projects, mutually exclusive alternatives with each other and learning the methods that can be used to select the best alternative. In our previous lectures, we talked about the useful lives, the study periods, the mutually exclusive alternatives, present, future, annual worth methods, and we were talking about the rate of return methods, and we have seen that while implementing the rate of return methods, sometimes if you select the project which has the highest internal rate of return, the final decision, final ranking of the projects can be different than the ranking of the equivalent worth methods. And it means that the two methods will give two different solutions. We call this as the inconsistent ranking problem, and we learned the incremental analysis procedure to overcome this. In today's lecture, we will summarize the incremental analysis procedure, solve several examples on this incremental analysis using internal rate of return and external rate of returns. So let's get started. So we mentioned that when we use the rate of return methods in comparing project alternatives with each other, we may end up with a problem. We may rank the alternatives in a wrong way. The present worth or equivalent worth methods may provide a different ranking than the rate of return if we just try to maximize or select the project which maximizes the rate of return. And this is called the inconsistent ranking problem. And in order to avoid this inconsistent ranking problem, we suggested last time this incremental investment analysis procedure. And according to this incremental investment analysis, what we do in the first step, we order the feasible alternatives, project alternatives, based on their capital values. We order them in increasing order. We sort them in increasing order. In step 2, we establish a base alternative, and this base alternative depends whether these project alternatives are cost projects or investment projects. If it's a cost alternative, then the first alternative, the alternative which has the minimum capital investment, is the base. Otherwise, if it's an investment alternative which provides revenues and economical benefits, then we check the alternative with the minimum capital investment. We find its IRR, internal rate of return. If this is greater than MAR, then we select this project as the base. Otherwise, we ignore this project, we find the next one, we select the next one, find its IRR and compare it to the MAR. If it is greater than MAR, then we select that one as the base. Otherwise, we ignore this project. We exclude this project also. Okay, so the base project, selection of the base project depends on whether it's a cost alternative or an investment alternative. Then, having these, after selecting the base project, then we compare each of the other projects in order with the selected base project by looking the incremental cash flows, the difference between the cash flows. Okay, and if the incremental cash flow between the next alternative in order and the current alternative is acceptable, we select the next one. Otherwise, we exclude the next one, it is not preferable, and we continue with the current alternative and we compare it with the next one. Okay, we continue this procedure until we evaluate all feasible project alternatives. And last time we solved an example using this incremental investment analysis where the projects were investment projects. Now let's solve another example problem in which the project alternatives are cost projects. So according to this project, there are 4 different diesel-powered air compressors. D1, D2, D3, D4 represent these. Their capital investments are given to us. Their annual expenses are given to us. There are no revenues associated with these. It means that all projects are cost alternatives. All of them have equal useful lives. And the market value at the end of their useful lives are also given. By this information, you can easily sketch the cash flow diagram of the alternatives, and the MAR is given to us as 20%. Okay, so we are asked to determine the preferred design alternative. We need to select only one of these alternatives. Okay, and we want to select the preferred alternative using the IRR method, and also using the same incremental analysis. We will still use the same incremental analysis, but this time not with the rate of return, but this time we will use it with the present word method, and we will see if this analysis with the present word provides the same analysis with the IRR. So let's start the procedure. Since all of these are cost alternatives, the first step is to order them with respect to their capital investment requirements. And as you can see, it's already D1 is the smallest one, D4 is the next smallest, then D2, then D3. So the alternative with minimum capital investment requirement is D1. And since these are cost alternatives, we don't need to look at the IRR of this one. It means that D1 is our base project. We select it as our base project. The next thing, we need to compare this base project with the next alternative, with the next higher capital investment. So simply we will look at D4 minus D1. Okay, and in order to look at D4 minus D1, we need to look at the differences between the cash flows. Okay, on capital investment, the difference is 22,000. Okay, so this is capital investment. For annual expenses, we need to subtract this one from this one, and it will be, as you can see, negative. Remember, these are expenses. I'm subtracting from negative to 22,100. I am subtracting negative 29,000, and it is positive 6,900. So now these are not costs. Okay, the difference now became revenues. This is plus. This is capital investment. It's still negative because I have subtracted from this minus 122,000. I have subtracted minus 22,000, and it's still negative. But these annual expenses, when I subtract this from minus 22,100, if I subtract minus 2,900, it becomes positive now. And also, I need to subtract from this market value. Okay, but these are already positive. Both of them are positive. So it is market value at the end will be 4,000. So if we sketch the cash flow diagram of this difference, so we will have 22,000 at time 0. Useful life is 5 years. And at each year we have positive 6,900, and additionally we have 4,000 at the end of these 5 years. Now this is D4 minus D1, and in order to decide on which alternative to select to continue with, in IRR method, I need to find the internal rate of return for this cash flow. And simply, how do we do it? I need to move everything to time 0. So this 6,900 P given A, P given A, okay, and the interest rate that we want to find, time is 5 years, plus the market value at the end. This time it is P given F, I, and 5 years, okay, and from this one, these are positive, I'm going to subtract the capital investment, which is already at time 0, and I will make this equal to 0 and try to find this I values, which will give me internal rate of return. So when we do it for D4 minus D1, so as we said, these are the cash flows, the useful life is still 5 years, and when we find the rate of return, we find it to be 20.5. Remember, in this example, the MAR was given at 20%. And since this rate of return is greater than MAR, 20%, it means that the increment is justified, so we continue with D4. Okay? We stop D1 being a base project, we exclude it. Now our new base project is D4. So this is IRR. Okay? If we use present worth method, again with this incremental analysis, what we do, we find the present worth of this cash flow. So 22,000 negative. For 5 years I have these earnings, and plus I have this market value. So MAR is 20%. So I need to find this the present worth of this cash flow using 20%. And when you do it, we see that it is positive. Since present worth is greater than 0, then we say that the increment is justified. Okay, so by using IRR, since this 20.5 greater than MAR, we said that yes, it is justified. In present worth method, we find that the present worth is greater than 0, so that we say that the increment is justified. Now our new base project is 4. Okay, so next one in sequence with the capital investment value, next highest capital investment value is D2. And since D4 is our now new base project, I need to look to the difference between D2 and D4. Okay, so from this capital investment D2, I'm going to subtract the capital investment of D4, which makes 18,600. Again, from the annual expenses, from this 16,900, I will subtract 22,100. Again, it is positive 5,200. So it is a saving now. Okay, it is positive. This one is expense, it's negative. And the market value from this one, if I subtract this one, it is 0. Useful life is 5 years. So again, using the IRR method, I need to find the rate of return for this cash flow. Okay, so this is 18,600 for 5 years. I have 5,200 and the market value is 0. And what is the rate of return, internal rate of return for this cash flow? And we find it to be 12.3. And this one is less than 20%, which is MAR. Okay, since it is less than MAR, we say that the increment is not justified. What does it mean? We cannot prefer D2 over D4. We continue with D4. D4 is still our base project. Okay, instead of rate of return, if we use the present worth, what we do, again, for this cash flow, we calculate the present worth of this cash flow, and it appears to be negative. And since the present worth of the difference is less than 0, we say that the increment is not justified, and we continue with D4. So rate of return and the present world provides the same result. Okay, so it means that if you use the incremental analysis procedure, the rate of return will give correct results consistent with the equivalent word methods. But if you don't use incremental analysis but just try to select the project which has the maximum internal rate of return, then you may end up with a wrong ranking and with a wrong decision. But the thing is, look, when you are given these project alternatives, for project alternatives, if you want to use the present worth method, you don't need to use the incremental analysis. You can just calculate the present worth of each one of them separately and select the alternative which maximizes the present worth. Okay, so there's no problem with this one. But if you find the rate of return, internal rate of return for each project alternative separately and select the maximum of them, then you may end up with a wrong decision. So this incremental analysis is necessary if you are using a rate of return method. Okay. Otherwise, if you want to use an equivalent word method, you don't need to use incremental analysis. But if you use it, still you will obtain the same result. And now at this step, we said that still D4 is the base project and we have one more remaining alternative, which is D3. D3 has the largest initial capital investment. And we will look at the difference D3 minus D4. And the difference between their capital investments is this much. Difference between the annual expenses, now it becomes savings, it is this much. Difference between their market values, it is this much. Useful life is given. And when you find the rate of return, internal rate of return of this difference cash flow, we see that it is greater than MAR. And since it is greater than MAR, the increment is justified. If instead of IRR you calculate the present worth of the difference, again we see that it is greater than 0, and since it is greater than 0, it is justified, and justified means that we prefer D3 over D4, and D3 becomes our current alternative or base project now. And since there are no other remaining projects, D3 is the selected project. D3 is the best project. What does it mean? The present worth of this D3 is the highest. Okay, so this is how we use incremental analysis on cost-only projects. Now let's consider another example. But in this example, instead of internal rate of return, we are going to use external rate of return. So in this example, we are given 3 alternative projects to increase the productivity of a flexible manufacturing center in an automotive parts plant. Okay, so the net cash flows for the 3 alternatives are given. It is said that the analysis period is 6 years and the MAR is given to be 20%. So we are going to find the best alternative, one of the alternatives, using the external rate of return method. And how do we do it? We will use the incremental analysis. We will use the same procedure as the IRR. Okay, so the first thing, look, there's this capital investment and associated benefits or savings. It means that these are investment alternatives. And since they are investment alternatives, the first thing is to select the base project. And in order to select the base project, first I am going to select the project alternative with the minimum capital investment, which is A. And then for this A, I'm going to calculate its external rate of return. And remember, how do we calculate the external rate of return? So if this is project alternative A, for A, the cash flow is something like this. This is the initial capital investment. At each year we have different amounts of revenues for 6 years. Okay, these are different. This is 262,000 and etc. Okay, what do? We shift every expense to time 0, and it's already in time 0. We shift every revenue to time n, the end of the study period, using MAR 20%. And then when we have these, we want to make this future value equivalent to future value of revenues to be equivalent to the present value of the expenses, and we want to find the interest rate that will make this equality. So if we multiply this value by f given p and then I and then 6 and make it equal to this future value that we obtained here, this I value will be our external rate of return. Okay, so first we do this with the alternative project which has the minimum capital investment, and when we do it, the external rate of return appears to be 28.3%. And what do we say? We say that since this ERR value is greater than 20%, which is MAR, since it is greater, then A is selected as our base project. Okay. Then we continue. What do? The next alternative, which has the next capital investment spending, we select that one and we look at the difference. So we look at the difference B minus A. So the difference between their capital investments and difference between their expenses at each year. By the way, this minus 40, since these are revenues, this minus 40 is an expense. At year 1, still for B, we need to do some spendings, and we subtract from the cash flow of B, we subtract the values of A. And with the obtained cash flow diagram, we will calculate its ERR, and if the ERR is greater than MAR, we accept the increment, otherwise we reject. So the analysis is here. For A, we first select it as the potential base project. We calculate its ERR value, and the ERR value is greater than MAR, so the increment is justified. It means that A is our base project. Then we compare B minus A, so these are the cash flows of the difference. So we find the present worth of the expenses, we find the future worth of the revenues, and we find the interest rate that will make this present worth equal to future worth, and this is our external rate of return. And since it is less than MAR, it means that the increment is not justified. It means that we cannot prefer B over A. And we continue with A. A is still the best project. Then what do? The next alternative is C, and we look at the difference, C minus A. So this is the cash flow. We find the present worth of the expenses and future worth of the revenues, and we find the interest rate that will satisfy the equality. And we see that since this is greater than MAR, okay, so the increment is justified, and we prefer C over A. So at the end of this analysis, we say that C is the best project. Again, we used here ERR method. If you use present worth method, you can use it as inside this incremental analysis, or you can use it at the beginning. You can just find the present worth of A, present worth of B, present worth of C separately, and find the project which has the highest present worth, because these are investment alternatives, and you select the alternative with the highest present worth, which will be again project C. C is the preferred alternative. So we can summarize the incremental investment analysis procedure with such a flow chart. So actually this flow chart summarizes what we did in the previous examples. In incremental analysis, we start by arranging or sorting the mutually exclusive alternatives with respect to their increasing capital investments. Then we need to select the base. And how do we do it? If it's a cost alternative, then the first one in this ordered list is your base. If it's an investment alternative, then the alternative project, the mutually exclusive alternative, which has the least capital investment and which is acceptable, is the base. And a project is acceptable if its IRR is greater than or equal to MAR, or if its present, future, or annual worth is greater than or equal to 0 when these equivalent worths are calculated using MAR as the interest rate. Okay. Then after establishing the current base, we select the next mutually exclusive alternative. And using this next alternative, we develop the incremental cash flow, meaning that for each year, we subtract the cash flow amount of the current base from the next mutually exclusive alternative. And for this incremental cash flow, we try to decide on if this incremental cash flow is acceptable or not. If the IRR of the incremental cash flow is greater than or equal to MAR, then it's acceptable. Or if the equivalent worth of this incremental cash flow is greater than or equal to 0, then it's acceptable. So if it is acceptable and if this is the last project, then we stop. Okay, so this current base at the end when you stop is your preferred alternative. If it is not the last project, then what do? We select this alternative as our current base and we return to this step of the procedure. So we select the next project alternative and then we develop the difference, the incremental cash flow, and we repeat the same thing. Okay. If the cash flow is not acceptable and if this was the last project alternative, then we stop. And the current base project at this time in your hand is the preferred alternative. But if it is not the last alternative, then we select the next alternative and repeat the procedure. Okay, so this is just a flow chart that summarizes the procedure of incremental analysis. So while implementing these rate of return methods, to select one of the alternative projects, usually 3 types of errors are done. These are common errors. What are they? Selecting the mutually exclusive alternative which has the highest overall internal rate of return on total cash flow. This is not correct. This is an error. Okay, it may, in most cases, it will provide you a wrong decision. Or the highest internal rate of return on an incremental capital investment. So you look at the difference between the projects and you select the one which has the highest IRR. Okay. It is not important whether the internal rate of return is higher or lower. You have to compare internal rate of return with MAR always. Okay, and the third error, common error, is selecting the mutually exclusive alternative which has the largest capital investment that has this IRR greater than or equal to MAR. Okay, so there are alternative projects. You find the project which has the largest capital investment and find its IRR and compare it to the MAR and you see that the IRR is greater than MAR and it has the largest capital investment, then you say that okay, this is the best project. But no, this is not the procedure, this is not the correct way, and most probably you will end up with a wrong decision here. So none of these situations is generally true. We have to implement this incremental analysis so that we come up with the best alternative, best decision at the end. So when you are using rate of return, don't fall into one of these three situations. Perform the incremental analysis in a correct way and you will obtain the best decision. So this is the end of this lecture. In our following lecture, we will start learning how to compare project alternatives with different useful lives, and these useful lives usually will be different than the analysis period.